All right, welcome back to another tutorial. In this one, we'll be talking about singly linked list as a data structure. So in this one, what we'll be doing is different operations, including insert, delete, search, and traverse, right? So basically, what exactly is a linked list? So whilst doing this code, we are going to talk about this. So the singly linked list is a linear data structure, right? Which in which elements are not stored in a contiguous memory locations. Instead, each elements are which are commonly called as the nodes have two different parts, a data and a pointer, right? Unlike arrays, linked lists do not have any kind of fixed size or grow, or they can grow and shrink dynamically by adding or removing different nodes. Basically, we'll be doing like three different kinds of linked list: single, double, and circular. So in today, we're going to do single linked list. The first thing that we're going to do is the simple stuff, which is going to be the initialization, right? We're going to do the init part. So first we're going to define the node, and then we'll create another class called the linked list, right? Okay, so in it, so there will be like basic three-step process for each of the things, right? The input operations where the data, where we create the new node with the given data, and then we made the new node's next pointer on the current head of the list, and then we update the head of the list to the point of the new node, right? Okay. Then what we're going to do is insert at the beginning. So insert at the beginning is pretty simple. As I said earlier, make the new node's next pointer point to the current head of the list. So when I have node number 1 and node number 2, node number 2's pointer will point to the next. Or let's just say node number 1's pointer will point to node number 2. So basically you can understand like where exactly is the first, where exactly is the second, third, fourth, fifth, and you can just understand that this after this node, this has to be there. After this node has to be there. So they're connected to each other and everyone knows who is behind them. Okay, so insert at the beginning is pretty simple. All you have to do is just self head new node and then just print it. All you have to add just is new data into the node. We just create an object and then we just dot next using this method, and then self dot head, and self dot head is our basically their new node. Then the next is insertion operation at the end. So all we do is create a new node with the given data as we usually do, and then traverse to the last node of the list and make the last node's next pointer point to the new node, right? So right now, what is our last node that we just added, let's just say we have three nodes, and so what is going to be our last node? 3, obviously. Then if we want to add the new node at the end, then we'll be adding a new node after 3, which is going to be our last node. So it's going to be pretty simple. All you do is just put the node of, this is too complex. All right, it's not too damn complex, it's pretty simple. All you have to do is just add a new node at the end of the entire linked list, and you have to just connect the last node to the new node which is added on the last one. That's it, pretty simple. You just don't need to overcomplicate it. Just make it as simple as humanly possible in your head, right? Okay. While last node dot next. Okay, then just say last node dot next is equal to new node, and then we're gonna just print that we had inserted the data at the end. Okay, so inserted data at the end. That's it. Perfect. Now, once we're done with that, we are going to do the deletion operations. So the first thing that we did was the initialization, insertion at the beginning, insertion at the end, and now we're going to do the deletion. So how do we actually delete the nodes? Deletion of the nodes are pretty simple. All we have is the key. So where do you exactly want to delete the node? Which node, or let's just say which node you want to actually delete. That is going to be the key. All right, so self dot head temp next, and what we're going to do is temp is equal to none. Then once we're done with that, so then once we are done with temp is equal to none, what we're going to do is print the deleted key of the linked list and then return. Right. So if temp is none, not none, if it's not none, then this is the thing that is going to happen, right? Okay. So we're going pretty perfect right now because we are deleting it from the frontal parts. If it's from the frontal parts, right? Temp is equal to the key. Okay. Then we're gonna do like the pre is equal to none, and while temp is not none, if temp dot data is key, then break. If previous is equal to temp, then temp is equal to temp dot next is going to be our approach, right? It's basically a little bit complex once you start doing this for the first time. It kind of gets a little bit complex because the single linked list, double linked list, and circular linked list are pretty damn interestingly complex in a way. Because if you want to actually truly want to learn these, how these actually works, these three different data structures, then you actually have to do the dry runs multiple times. Like multiple times, that means I'm trying to say like 10 times, 15 times you have to do the dry run stuff to actually understand like why is these things happening after doing these things. Because I actually learned things the hardest possible way. It took me 3 months to learn these three data structures precisely. Like 3 months it took me. But I'm telling you the easy way. You have to do the easy way, and easy way is to start with the dry run stuff. You have to just do the dry runs multiple times. Then you have to understand why this particular thing is causing this particular thing, and then you start to actually understand why am I using these things in these places. And once you start understanding that particular concept, it's going to be pretty damn easy for you to understand why is these things are used in these places, and you'll be able to create your own, recreate this entire program without even looking at it. So temp is equal to none, and then we'll be saying the deleted key from the linked list if it actually finds out the deleted key. It's gonna be deleted key. And once we're done with the deletions part of this, we're going to do the search. So search is basically pretty simple. In search, we're going to do the current self head, and then we just have to search the key that we have given. Let's and then we have search and traverse are the last thing that we're going to do. So let's just do the current is equal to self head, and while current, let's just say current dot data and end and current dot next. So traverse is pretty simple. Traverse is pretty simple. You have to just do the basic stuff, the current dot data, and you have to just give the end. So end is basically going to be, traverse is going to simply show you how the linked list is basically set up. So the first element, then it will show like the arrow sign. I'll just design this arrow sign, and then you'll have the next element, next element, next element, and next element. Traverse is going to be a visualization of the data of the, let's just say, linked list that you have. It's that simple. So we're done with this. Now let's just create the object of our class linked list. Let's just call it LL, capital L and small l as our object to the linked list. And then we're going to access all of the functions that we have just created. So the first thing, insert at the beginning, I'll just add a random element, let's just say 10, and then I'll be inserting one more element at the end, let's say 30, and then I'm gonna maybe, what should I do with this? Insert at the end again 40, and then what we're gonna do is do the traverse part of it. Okay, it's traverse. Okay, is spelling right? Traverse. Bad with the spellings. All right, so then again LL, and then I'm going to do the deletions of node, and I'm going to delete, let's just say 10 as the first node. And then I'm going to do the traverse again to see how much changes does it made. And then we're going to do the result part and everything. All right, so result is going to be pretty simple. Result is going to be ll.search. Search third, let's just say, okay, let's just say what shall I search, 30, 40, 30, and then I'm gonna just search where exactly did I find the particular data. So result.data will be the place where I actually found the node that I just gave. Okay, then the else part element not found, right? All right, it's going pretty damn simple. I guess we have an error up here, and okay, we can pack it done. So print element not found is the last thing that we have to do. Okay, so we're good to run our program. We are actually totally done with this entire setup. This is 18.py and running this program. All right, it caused some kind of error at line number 57, and line number 57 says transverse error. Right, let's just see. Did we even everything is going pretty fine. I think we have some sort of problem. Okay, up here, I think we haven't defined the traverse method at all. I think we confused the between part. I actually named the search as traverse and I forgot to define the search method, right? Sometimes these kind of silly mistakes happen. So that was traverse, and the search will be pretty simple. Current is equal to self head, and then we are going to do the while loop. If current is not none, then we are going to just do if current dot data is equal to key, and if it is, then return the current, and if it's not, then current is equal to current dot next, and then we can do the loop again, and we're going to execute the loop again and again and again until we find the key. And once we find the key, return the current. That's it. And if we don't, then return none. If we don't find anything, return none. All right, now I think it's gonna be working perfectly. Let's just run this again, and it is creating an endless loop. So I think the endless loop is causing because we forgot a step up here, and the step up here is the next. Current is equal to current dot next, because it is continuously iterating over the same thing and it is not incrementing the value, and that's why it's happening, right? So let's just say next, and we are done. Now it has to work, and it's perfectly working. You can see every single thing is working perfectly damn near good. You can just see all of it is working. So you can go onto the link in the description. You'll find every single code that we have been doing since the day one of this. And as you can see, everything is pretty damn great. So see you in the next one with some new data structure.